Lesson 18, Solved Problems, Part 5. Examples, number 26. A boy blew his rubber balloon to a spherical shape. The balloon burst when its diameter is 15 cm. Calculate correct to the nearest whole number the volume of air in the balloon at the point of bursting. Solution: volume of air at the point of bursting is equal to volume of the spherical shape formed by the balloon. Volume of sphere is given by this formula. The radius is needed because we are given diameter. Radius is diameter divided by 2, that is 15/2 cm. You come here, you have 4/3 times pi, 22/7 times radius 15/2 to the power of 3. If you simplify this term, you write it in this form and the other two fractions. When you cancel out common terms, you have this result. When you multiply, you have this result. After division, you have this result. The volume to the nearest whole number is approximately equal to 1,768 cube centimeters. Example 27. A hollow sphere has a volume of k cube centimeters and a surface area of k square centimeters. Calculate the diameter of the sphere. Solution: diameter d is equal to 2 times radius. So we need arrow the radius. We use the two given terms, volume and surface area. Volume of sphere is given by this formula. The volume is k equal to 4/3 pi arrow cube. You make arrow cube the subject by first multiply through by 3 to clear fraction, then divide both sides by 4 pi, and you have equation 1. Using surface area given as k equal to 4 pi arrow square, you make arrow square the subject by using 4 pi to divide both sides. You have this as equation 2. To proceed, divide equation 1 by 2. You do that side by side. This is first side of equation 1 divided by first side of equation 2 equal to second side of equation 1 divided by second side of equation 2. You have it in this form. If you divide arrow cube by arrow square, you have arrow equal to, you change this sign to multiplication, you invert this fraction, you have this result. 4 pi cancel 4 pi, k cancel k, arrow is equal to 3. Diameter d becomes 2 times 3, and that is 6 centimeters. Example 28. Two solid spheres have volume 250 cube centimeters and 120 cube centimeters respectively. Find the ratio of their radii. Solution: solid sphere 1 ratio solid sphere 2 in terms of their radius for this and for this. The volume is given by this formula. Solid sphere 1, the volume is equal to 250 equal to 4 over 3 times 22 over 7 times arrow cube. Multiply through by 3 times 7 to clear fractions. Divide both sides by 88, the product of 4 and 22 in this form, and you have 59.659. Take the cube root of both sides in order to get the radius of the first sphere, and you have it to be approximately equal to 4. Solid sphere 2, the volume is 128. If you carry out similar operations here, you have the radius to be approximately equal to 3. Therefore, ratio of the sphere's radii is 4:3. Example 29. A hemispherical tank of diameter 10 meters is filled by water issuing from a pipe of radius 20 centimeters at 2 meters per second. Calculate correct to 3 SF the time in minutes it takes to fill the tank. Take pi equal to 3.142. Solution: you have the tank in form of hemisphere, the water flowing in from the pipe. This is the diameter of the tank. Volume of hemispherical tank is equal to 2 over 3 times pi arrow cube. The radius is needed, which is equal to diameter divided by 2 equal to 10 divided by 2 equal to 5 meters. Therefore, volume is equal to 2 over 3 times pi times radius cube. You have this result. 5 cube is 125. When you multiply, you have this result. After division, you have 261.83 cube meters. Note that pipe is a special type of cylinder. Volume of water per second is equal to volume of cylinder per second of water flowing from the pipe. The radius of the pipe is given to be 20 centimeters. We need the same units. The first part we used meter, so let's convert this to meter. You divide it by 100 and you have 0.2 meters. The height is equal to 2 meters. Volume of water is equal to pi times radius square times height equal to 0.25136 cube meters per second. Time taken in seconds is equal to volume of tank over volume per second of pipe. This is the volume of tank divided by volume per second of pipe, and you have this result. This time is in seconds. The time is required in minutes, so you divide this by 60 and you have it in minutes. To 3SF, you have 17.4 minutes. Example 30. A triangular prism of length 10.5 cm has its cross-sectional length 3 cm, 4 cm, and 5 cm. Calculate its volume. Solution. This figure represents the given information. The shortest side is A, that is 3. You have 4, and the longest side is the hypotenuse, considering the cross section area, which is a right-angled triangle. Volume of prism is equal to base area times height, also equal to cross-sectional area times height. The cross section is a triangle whose area is given as half times base times height. Before the height of the prism, so B represents the height of the prism, which is 4 cm. The cross-sectional part of it, the height is 4 cm, denoted by B. So you have 1/2 times the base 3 times the height of the cross section 4 times the height or length of the prism 10.5. When you simplify, you have this result. After multiplication, you have 63 cube centimeters. End of lesson 18. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.